we're going to talk about two things in relationship to theory evaluation. And basically, one is focused on how do we use a theory for making predictions, testing those predictions, and then using the test of those predictions, the data, to update our beliefs about the theory. I've already started talking about the Bayesian, like a Bayesian, but you know what I mean, right? So how do we use our results, basically the steps in the empirical cycle, for making changes in our theories? That's the first step. And the second step is how to evaluate theories given a list of different criteria. And that's more related to comparing and selecting between competing explanations. So a theory A and theory B, which one should I prefer given all those criteria and given the data I just collected? All right, so first of all, it's important to talk about the need for theory. And we're going to do that, why theory is relevant at all, right? Because there's also people who are convinced that it isn't. I'm trying to convince you briefly that it is. It has to do with two songs. The first one is The Power by Snap, and if you don't know it, you should look it up. And it's very lame. I think you would judge it to be lame now. I think people were pretty wild about it by the end of the 80s, beginning of the 90s. And you have some basic synthesizer music and somebody screaming, "I got the power!" And that's basically the whole song. Right? Exactly. Thank you. Yeah, we could have continued that, but I already stuffed it. But that was music. Yes, thanks. And it's an interesting way of talking about power, right? Having power or being a powerful person is, you could call that a psychological characteristic, right? So it's something that psychological theories apply to. And people talk about it in terms of having it, right? I'm an individual and I have the power, just like He-Man in another throwback to the 80s cartoon from that time talked about having the power, right? So it assumes that something resides in you, right? I have the power, and it's I don't know how it works, but it's in me. And if I'm a powerful person, that means that somewhere in me there's power, and I can use that to influence other people. But in doing so, I'm making an assumption, which has been called atomism. That's not something I'm going to test you on. This is just an example of the type of assumptions we make when reasoning about psychological processes. So according to the assumption of atomism, which is a very basic assumption, we look for explanations for psychological functioning within the individual, right? So if somebody is a powerful individual, that must be some observable in that individual itself. And processing taking place in that individual or observable by observing the behavior of that individual. Self-esteem, we talked about power, but self-esteem, it applies the same, right? So if somebody has low self-esteem, we tend to generate our ideas or explanation by looking at that within that individual. But you could also argue, which Hans van der Maas basically did last week, that power or self-esteem is not a property of an individual, but a property of the relationship between individuals, right? And then you would be making a different assumption about what power is and how it should be, how you should do research on it. All right, so that was a bit of, I like this example because it goes back to your fundamental assumptions. The specific assumption isn't that relevant, but hopefully it shows you that it's useful to make your assumptions explicit. And theory is one way of making your assumptions explicit. Basically, you're putting all your assumptions about the relevant process together and showing to the world and your colleagues, this is what I think how this process works. And these are the assumptions that I'm making about it, which you can then test. Or you can at least make explicit what assumptions you can test and what you don't test with your research. All right, so we need research because we need to map out the assumptions we're making about the processes we're interested in. Another reason why we need theory, and another song, I can't sing this, but you know the Hey song, right? It's from the 2000s, the noughties, I guess you call it. Then there's it's more of a dancing song, right? Or at least it's what I danced to back in the day. And there's a part that I think it's the bridge of the song, and they sing "Shake It Like a Polaroid Picture," right? And that stuck with me.
Shake it like a Polaroid picture.
Exactly. Thank you for that. Wow, yeah, that's exactly what they sing. And you see people dancing as well. And what you see basically is the influence of technological development about how we think about, in this example, dancing. So, right, so you shake a Polaroid picture in a way, and then that leads to, well, you can shake other things in that way as well. I mean, you can forget the examples, right? I mean, it's just a way of making sure that these topics stick in your mind, making it somewhat more interesting than just dryly talking about theory. What you see is technological developments influencing our assumptions about, well, behavior. And that's what you also see in development of statistical tools, for example, statistical technologies in how people theorize about psychological processes. And you could argue that that's a bit too simple, right? So, because we're so used to using null hypothesis significance testing, we're very used to asking yes or no questions, right? So does that group differ from that group? Does this group differ from that group? On what levels? Is there an interaction, right? So those are the questions we're used to asking in a statistical sense, and that influence the way in which we theorized as well. One very explicit example is the Kelly's causal attribution theory. We talked about this in the first year, right? So the degree to which you think that you can attribute somebody's behavior to being caused by their personality or their external circumstances depend on how much variation we observe within that person compared to the variation we observe between persons. So that's literally a derivative of what you do with an ANOVA. So what this shows, and the reading talks about it as well, is that the tools we use for testing our statistical hypotheses seem to have a direct influence on how we formulate our theories. Another example, and the details you don't need to know, but there's a model of using your feelings as information, right, while making a decision. Then you have this, it almost seems like a board game, right? So do I experience feelings? Yes. Are those feelings representative? Yes or no. Are the feelings relevant? Yes or no. Do you have general trust in feelings? Yes or no. And you see a lot of models are like this in psychology. And you have to ask yourself, is this really the best way to model decision-making and the influence of feelings on decision-making? Or is it basically a direct result of the way in which we test hypotheses by basically saying, was there a difference observed between the representative group and a non-representative group, and such, you ask all those yes or no questions and test your null hypothesis. Basically, what I'm saying is that statistical techniques have perhaps an undue influence on theorizing, and we need to be explicit about that. We need to be aware of the fact that the way in which we reason about theories might be, well, almost a direct reflection of the statistical test we've used, and that might not necessarily give the best reflection of the stuff we're interested in. All right, those were two reasons, right? So we need to map our assumptions, and we need to be on the lookout for, our statistical techniques influencing our theorizing in an undue way. But we also need to connect research findings. That was also something I struggled with in my studies, is that once you start your specialization, there seems to be an explosion of information. Perhaps you've experienced this in your first year as well, right? So there's all these different theories, and it all sometimes seems like they're saying the same thing but giving a different label to it, and sometimes that's actually the case. And that's because the information, the massive information that has been generated by psychological research has been called the knowledge explosion. And some people have called it a explosion in a confetti factory, right? So there's all these beautiful bits of paper floating around, which are all interesting by itself, but they seem to be unconnected. No one is making the connections for you between the different research results that have been produced. And we need that integration. If you want to be a scientist practitioner and you want to make good predictions about behavior or understand people better, then you are not well served by having that explosion of different research results. You want to have interconnected an interconnected web of research results, which all build into a well-tested theory that you can then use for predictions or better understanding of people. So we need be explicit about our assumptions, that's why we need theory. We shouldn't be too influenced by our statistical techniques, that's why we need theory. And we want to have a proper understanding of psychology, and we want to connect the different research results that we do encounter. So we need theory. We also need theory, of course, for setting up predictions, as you've been taught, right? So you, in the hypothetic deductive model or going through the empirical cycle, you do an observation, you think, well, that's interesting, and you wonder about, well, this could be the case, you set up your theory, and then you make predictions, you derive it from that theory. So you need it for reasoning from theory to experiment. So, for example, what you might remember from the first year, right? You read a paper about prosocial behavior, measured by people dropping pens and looking at whether the participants were willing to pick them up, and that was considered to be prosocial behavior. The predictions were made on the basis of a theory which was called the perception-behavior link, which basically means if you observe something, perhaps a perception, you're more likely to behave in a similar way. Behavior, perception-behavior link, right? That's the whole theory. You mimic people, or you perceive some similarity between people, and then you're more likely to help people out, is how they reasoned. And the perception-behavior link also was applied in John Bartsch in his research on why people would walk slower to the elevator after participating in the experiment once they were primed with words related to the elderly. Right, so elderly related words make a certain stereotype more accessible, and that stereotype guides your behavior in a certain way. So I'm all giving you examples of a theory. The perception behavior link was used to predict stuff about prosocial behavior. It was used to predict stuff about walking slowly. And I'm going to use it as an example of how you should ideally reason, and how that in practice happens when you go in that empirical cycle from your substantive hypothesis depicted at the top, what we usually call your theory, to a statistical hypothesis in which you test a specific prediction, and then you reason back to your theory, right? So your substantive hypothesis might be that activation of stereotypes cause people to behave in line with the associated traits, right? That's the perception behavior link. You need to argue for that, right? So, and you can use previous research or whatever to say that this is your hypothesis. Sometimes you could even say that you don't even need it, any reasoning behind it. This is just your real theory, and you're going to test it. But what you do need to argue is how you derive a certain research hypothesis from it, right? So you have expectations about how stuff will happen in your research on the basis of your theory, but it's more specific to the context of your actual research and your operationalization and your measurement. So this is a more specific version of what's listed here, right? Here we're generally talking about stereotype activation and behavior, and that becomes more specific if we say that we activate the elderly stereotype and that leads to slower walking speeds, right? The behavior is more specific, and the stereotype activation has been made more specific as well. Ideally, you're able to argue as a researcher that given that this assumption holds, this is also likely to happen, right? That's basically what you're saying. So there's this general theory of behavior, and in this specific context of my research, this is likely to happen if that theory holds. So every arrow is a step in your reasoning that you need to substantiate. Researchers not often do. They rarely do, in fact, but that's indeed something you could perhaps improve on as future researchers. Indeed, in the articles about perception behavior link, there's no substantiation whatsoever why this general assumption would lead to this specific prediction and not something else. From that specific description, you derive a statistical hypothesis, which you then test. In psychology, that often means setting up a null hypothesis and trying to reject it. I'm making that explicit the final step, even though you're familiar with it, because it is indeed a step in your reasoning. So you need to argue why being able to reject a null or not is in any way relevant to what you believe about your research hypothesis and your substantive hypotheses. So that's the main takeaway. These are active steps in your argumentation that should be convincing to you, and you should be able to convince your audience of. And that not often happens. What we see in practice is steps that will be skipped, right? So this is an example of how such an argumentation would look, right? So we're starting at the upper level, what's depicted in the lower level here. So if we're gonna, what we just did was reasoning from the substantive hypothesis to the statistical hypothesis. So how is this derived from that, and how is this derived from that? And let's say you test that statistical hypothesis and you're able to reject a null, then you can reason back to your theory. Again, in that idealized way, that would look like, well, I've rejected the null hypothesis, or I found a significant p-value. If the p-value is significant, then I can reject the null. And the first conclusion would then be the null can be rejected, right? We're still on the statistical level. If we say that the null can be rejected, that has an implication for our theory or assumptions on the research level as well, which can then be generalized to the perception behavior link that we were interested in the first place. If you would make those steps explicit, they rarely are explicit, as you've probably seen in your Pechacucci assignment last month, then it's easier to be critical as well, or critically reflect on how the steps are being taken. For example, if you say that, well, showing words, elderly related words to people makes them walk more slowly, it should be convincing to you that that is indeed likely to happen if the theory holds. And you, critical thinkers as you are, I hope that you recognize that, well, the theory is a bit vague, right? If you activate whatever behavior can be, stereotype related behavior can be expected. So what does that mean? Before the experiment, you could predict if you would show people pictures of the elderly, for example, I mean, that could lead to the accessibility of any type of stereotype-related information, like bingo or slowness, or perhaps you're more likely to think of poodles once you think about the elderly. And why is slowness more likely to be activated than any of the other potential associations that people have with elderly related words or pictures in this case? And then the next step is, we're still talking about these steps here, is why, if indeed it is the case that slowness is the likely most activated construct, given that you show people elderly related words, why does it then mean that you're more likely to walk slow yourself? Why doesn't that mean that you're more likely to talk slowly or start walking faster because of a, I don't know, contrast between how you view yourself and the elderly? What I'm saying here is that it's not that self-evident, right? And in the case that if a theory is so vague as the perception behavior link, you should have that gnawing sense of, well, perhaps they didn't predict anything in advance. They just wrote the paper that way, and they came up with a, well, theoretical sauce on the research results, and not a proper theory from which anything could be predicted, right? Because there's no argument to be made that slowness is more likely to be activated given activation of this category, and that this behavior would be more likely, given activation of that category. So it's unclear how slowness and the elderly are related. It's also unclear to what degree we actually measure stereotype activation, right? So if you would ask, after reading these results, the researchers, how do you know that the stereotypic trait of the elderly was activated? They would say, well, people walk more slowly to the elevator. So the measure by which, so measuring speed is presumed to be an effect of stereotype activation, but both stereotype activation as well as walking speed are measured in the same way. And that's weird, right? That seems like a form of circular reasoning. And we're going to talk about why rejecting null hypotheses isn't a strong test of a theory in a while. So what I've tried to give you is an example of what ideally happens if you reason from your theory to your statistical hypotheses and back again. That's not always what happens, but it is something you should be on the lookout for. So the researcher is explicitly or implicitly taking a step from his or her theory to what they predict in their experimental setting, and then to the statistical hypotheses and back again. And you should be on the lookout for different forms of pseudo-reasoning that can play a role in taking those steps.